Okay, so the derivative is all I'm going to do on this one, even though it wants us to find the equation of the tangent line. Again, finding the equation of the tangent line, you would have your three columns. The first column would be y1 is equal to f of x1, right? That's going to be in your first column, and then we can solve that out, and we end up getting that y1 is equal to, I believe it was ln of 5 over 4, maybe. Let me look. Yeah, ln of 5 over 4. Okay. And that's not ln times 5 over 4, that's ln of 5 over 4. And we can remind ourselves that our x1 is equal to 2 right here. Okay. All right, and then in our second column here, we would have to find the derivative, or find the slope. So m is equal to f prime of x1. In order to do this, we have to find f prime of x before we can plug in x1. All right. So the derivative of ln of x. Anytime you have, so if y is equal to ln of like g of x, golly, getting ahead of myself here. All right. If y is equal to ln of g of x, then y prime is going to be, draw a line. Ln reminds us of the word line. Take what's on the inside and put it on the bottom. Take the derivative of that and put it on the top. So on the inside of the ln is g of x. The derivative of g of x is g prime of x. Okay? So in order for us to do that with this, it's not really going to be too horribly difficult, other than the fact that I have to do the derivative of the inside part, which is kind of crappy. So first things first, I know that f prime of x is going to require a line of some kind. And I got to put what's on the inside on the bottom. That's the easy part, right? So that gives me an x squared plus 1 over 2x. All right, not a problem. This part's the problem. All right, this is x squared plus 1 over 2x prime. Yay! All right, now we need to work on this. Okay? So doing this is going to kind of mess up my three columns, but your columns can be as wide as you want. Yeah. All right, so I've got to do either the quotient rule, or because this has a single piece in the denominator, I can split this up based on the fact that if I have a plus b all over c, that this does equal to a over c plus b over c. Now, with this, I want to remind you that it does not work the other way. You cannot have e over g plus h. This does not equal to e over g plus e over h. Do not ever do that. Now, I remember this, and I never made that mistake because I put it just like this when I took this class a very long time ago. I wrote it like that in red on the top corner of one of my pieces of paper, and it, for some reason, it was just there, and I was like, does not equal. This does not equal this. This works, but this doesn't. That was a mistake that I personally made, and so I know that most people would tend to make that mistake if you haven't seen it in a while. So just as a reminder, don't do that. All right, so working with this, I'm going to split this up. So this gives me x squared over 2x plus 1 over 2x. Now I'm going to do some canceling of this. And that's going to lead me to want to move my board around. All right. X squared over 2x, I'm going to have an x that cancels from top and bottom. And then I've got a 1 that's right here, right? So I'm going to rewrite this first piece as 1/2 x times x over x. I'm showing you every step because I don't want you to get lost. I can get rid of those 2 x's if I want. Or I can get rid of the other 2. I don't care. All right, so that's that one. This other one, this x is to a positive 1. I don't want it on the bottom. So I can say plus, I still have my 1/2. Then I'll just say x to the negative 1. Okay, I gotta finish this. So this is just bringing this one up. This would give me like times x to the negative 1 over 1. All right, then cleaning this thing up is going to give me 1/2 times x plus 1/2 times x to the negative 1. All right, this is 1/2 times that. Well, 1 times this, and then 2 times 1. You just go straight across. All right, 1/2 times that. All right, now we can take the derivative. I haven't done anything yet. Just been doing some algebra crap. All right, now taking the derivative, 1/2 times x, the derivative of that is just 1/2, plus negative 1 times 1/2 is negative 1/2, x to the power of negative 1 minus 1 is negative 2. Now we need to rewrite this with our exponent in the denominator. So that gives me a 1/2 minus 1 over 2x squared. And I don't have to do this because we're just going to plug in numbers, but I can get a common denominator here by doing an x squared on the top and on the bottom, multiplying, right? So then that gives me the final derivative for the top, again, which is just going to be equal to x squared on top minus 1 over a single denominator, 2x squared. Okay, now we're going to take this crap and we're going to plug it in over here.
Yeah.
All right. So my derivative becomes f prime of x is equal to, what the hell was it? It was x squared something over 2x squared plus or minus 1, I don't remember, minus 1. X squared minus 1. All right, so we have that divided by our original one of x squared plus 1 over 2x. There's your derivative. All right. Now, what we do with this, if you have two fractions that are divided by each other, what do you have to do?
Multiply by the reciprocal.
Right. I like to say flip and multiply because multiply by the reciprocal is a tongue twister. So, do I need to do it? I don't need to do it, but I'll just show you real quick. So 2x squared minus 1 over, x squared minus 1 over 2x squared times 2x on top over x squared plus 1. All right. 2's cancel. This x and one of those x's cancels. So then this just leaves me with my derivative being x squared minus 1 over x times x squared plus 1. Okay, this is my derivative. That's f prime of x. Now all we have to do is f prime of x1. All right? x1 is 2. Now, remember how I told you we're just going to plug in a number? I could have stopped right here and just plugged in the number.
Yeah.
Okay? The hard part about doing this entire problem is this stuff.
Yeah.
Right? So, all of this is what makes this one problem difficult. Other than that, this problem is a breeze.
Yeah.